Hi, I'm Lars. Welcome back to the C# workshop. The intent of this video series is to form a solid foundation that can be built on during your journey of becoming a developer. This first video is going to deal with managed memory applications and a little bit of a deep dive into value types. Are you ready to start your journey? If so, let's get to it.
Just like the last video, this video will get you the information that is needed to learn C#. In order to get the most out of these videos, I recommend watching them in their intended order. There will be deep dive videos after the course. Something that helps a lot when you're a developer is knowing how a computer program actually works. When you're in an operating system such as Windows and you double-click on a managed code.NET application, the operating system creates an area of memory for the application called an application domain. It then loads the application into that application domain. This isolates all managed code.NET applications in memory from one another. You can think of the application domain as a game loop. Basically, it will run until the operating system shuts it down and removes it from memory. The application domain then calls the main entry point on the application and your code executes. Unmanaged code is unaware of application domains. A game loop runs until it is told not to run anymore by the operating system. The application can send a request to the operating system to shut down the application. For instance, selecting File, Exit. Once the application finishes up all its work, the application asks the OS to remove the application domain from memory. In Windows, we can also press the X in the top right corner, which adds one more step to the process. The OS sends an event to the application to finish up its work, and when the application finishes its work, the application then lets the OS know the application is done working, and the OS removes the application domain from the memory. In Windows, we can also go to the Task Manager and end the task program. Windows shuts the application domain down without letting the application know. The OS just removes the application domain from memory.
There are many types of applications, and the simplest yet very powerful type of application is a console application. The odd thing is most developers that I've met in my career will write a batch script or a PowerShell script or a Python script for the very same task. A console application written in C# is more scalable, it will run faster, you can multi-thread it, and if you use a DLL to put the logic in it, you can take that DLL and incorporate it into any type of other application, like a website, desktop app, whatever.
When you start a console application, you're going to come into Open up Visual Studio and you're going to end up on the Start screen. Right now I don't have any recent folders or projects, but if you would, they would be listed over here. You're just going to click on Create a New Project. In here, you're going to click on Console App, which is right here, which I have pinned because it's one that I use a lot. Other ones I use a lot are Blazor Web Apps. I use ASP Core Web Apps. I use Web APIs, and you cannot forget class libraries. And click on your console app. Click Next. Project name Console App 1 is just fine, and we're going to stick this in YouTube Lars Workshop. Will be just fine a place to put it. And we're going to use .NET Standard Term Support. If you need the basics of Visual Studio, like installing it, a tour, or any of the hotkeys that are out there, I have a video covering the basics of the IDE for new users. Just go look it up on the channel, and I'll put a link in the description below. Applications are made up of a solution and one or more projects. This one here has one solution, that's all you can have, and it will also have, this one only has one project. You can have multiples. The project CS file is what we were referring to as the main entry point of the application, which means the instructions here will get executed first. So we'll start here with this write hello world. It'll be the first thing, and at the moment will be the only thing that we will see when we run the application. So let's fire this thing off. And remember, this is also F5. You click here on Console App or click F5. And there it is. Hello world. As you can see, we are back to the IDE. Everything's back to normal. And this tells you that this thing has been debugging, automatically closes the context when the debugging stops. Press any key to continue. So what we need to do is we need to put something in here like console.readline. Don't worry about these commands yet. We'll get more into them. I'm just trying to go through showing you how this is running in the operating system. So again, we're going to run this. The read line will actually hold that application there until we hit enter. And as you can see down here on the right, console app exe is here. Now, once I hit enter, that exe will disappear and the application domain gets shut down. Once the application domain is shut down, that means it's going to be removed from the task manager. It's the easiest thing to check. Now, something that's really neat about this is when we go up to here and we click this button, now you can see all the hidden fields. Underneath .NET 9.0, we're going to right click and we're going to say open the folder and bring us down. And these are this is your actual code that was just up here written, and this was all compiled. So if we take this and we change this code a little bit here, so what we need to do is we need to figure out, if we execute this, what is the PID over here that we're going to get, the process ID. So I'm going to add this in by putting a using statement in here. And the using statement will be system diagnostics. And we're just going to add in here process.getCurrentProcess.id. And that will display hello world and then the ID of the process. You will notice that there's 3 little dots here that will come in, and you could use environment process. It just tells you the quicker way to get to where you need to be. All right. And then we're going to build this with Control-Shift-B. On success. And we go back to here, built at 1:40 p.m. on the 5th. So we're going to run this. And lo and behold, we have 6256. And we're going to run it again. And that's another process ID. And we're going to run it again. And that's another process ID. Now you remember in the example, I had these 3 things sitting across the top like this. I'm going to minimize this. 3 things here. These are not running within Visual Studio. These are actual applications that are live in the wild, is what I call them, on my machine. And at the bottom, we have Task Manager. Now I could sit here and search up and down for these, but I'm just going to type this up in the top here, console app. And you'll see there is 6256, 40260, and 1372. So if you like, you can switch these around. So now they're in order of how they're listed in the Task Manager. And the first thing that we did is we hit File and Exit. Well, our File and Exit is just hitting Enter. And then see how that disappeared? So what happened is when we hit Enter, our application first completed what it was doing. Okay, if you would have had an application that was a graphical application and you hit File Exit, you might have gotten something up that said, you have an open file like in Word, do you want to save this? Or do you want to discard it? Or do you want to cancel and go back? We don't have any of that, so it just shut down. So what happens is the application shuts down, it tells the operating system, hey, I'm shutting down. Then the operating system removes the application from the application domain, and then it gets rid of the application domain, and everybody's all happy. All right. The second one we did was we just hit the little X up in the corner. And that did the same thing. Okay. The only difference was when we hit the X, the operating system sent an event, if you will, a message to the application and said, hey, someone's requesting you to be shut down. You need to take your shutdown procedure just like the very first one. And then the third one is when we come in, we just end the task. And that is your question you're going to get. Do you want to end the console application if an open program is associated with this process closed and you lose all unsaved data? You will end the system process. It might result in the system being unstable. Are you sure you want to continue? So like I was saying in the slides, is that This guy is not going to notify your application. It's just going to remove the application. Anything in it will be removed from memory, just like that, and we're done. Since most of the people watching are new to programming, at least in C#, I'm going to cover the aspects of development related to the real world. For those of you that have been coding for a while, you might see a new way of looking at a problem which will get you to the right solution faster than you do now.
Hey, if you think there's too much information to remember, then like and subscribe to the channel. Then you'll have a URL that you can go back and look at anytime.
This is what we're going to cover in this video. Value types are made up of bools, chars, integral numerics, and floating point numerics. A char or character is any alpha or numeric or special character on your keyboard. Bools defaults are false. The char's default is a \0. Integral numerics defaults are 0. And floating numerics are defaults are 0. So in order to fully understand data types, one needs to understand memory. Once memory is understood, then the declaration of a data type will make a lot more sense. Whether you have a hard drive or memory, it pretty much looks the same. Every bit of data has an address and a data stored in hex, because hex takes up less space than a stream of bits. I'm not going to get into that hex conversion explanation right now, maybe later in a video. So right now, let's just don't worry about it. It's just being stored differently in the hard drive and a memory. So the smallest particle in data is a bit, and every data type can be broken all the way down to a bit. Data being used by the CPU is in a bit stream. A lot like what happens when a movie is watched on Netflix or Hulu, and that is what applications use to send and receive application data. They send bit streams. So a lot of this is dependent on the compiler and the CPU, but longs, ints, and shorts are all made up from bytes, and a byte is 8 bits. So if you look at the integral numerics, 8 bits make a byte, 16 bits make a short, or 2 bytes, 32 bits make an int, or 4 bytes, and 64 bits make a long, or 8 bytes. So when you're thinking about bytes, shorts, ints, and longs, this is probably what you're thinking, that these things just keep on getting longer out to the right. Reality is they go the other direction, and there's a reason for this, and it all has to do with these positions in the data type. The bitwise positions of the string start on the right and they head to the left. So the first 0 is position 1, the second 0 is position 2, the third 0 is position 3, and on and on and on. Each one of these have a value which is here above. So position 1 has a value of 1. Position 2 is doubled and has a value of 2. Position 3 is then doubled, and so it has a value of 4. Position 4 gets doubled, it has a value of 8, and so forth and so on. So you'll see it goes 1, 2, 4, 8, 16, 32, 64, 128, 256, and on and on and on. This way, the numbers can be read from left to right. So as you can see by the listing here, if we're just looking at a byte and all of the digits, all the positions are 0, then the value is 0. If the first position is flipped to 1, it's a 1. If the second position is flipped to 1, then the value is 2. If positions 1 and 2 are flipped, then those two numbers are added. The values are added to 1 plus 2, and you're going to have 3. So basically what you were looking at is anytime one of these positions is flipped from a 0 to a 1 or turned on, you add all of the values up here at the top together to get the value you want. For instance, if they were all set to 1, the value would be 255. So with this information, keep in mind that you can take a byte and put it into a short very easily. You can take a short and put it into an int, and an int put it into a long. But going the other direction is not impossible, but you have to deal with something called casting. So now let's get over to the code and see how all this can be done in C#. Okay, so what we're going to do is we're going to use the same console application that we used at the beginning of the video. The only difference is I'm going to change out this console to be writing out value types. We're going to drop in a comment here called bool, like that. Now this bool could have this comment could have just been put in by putting 2 slashes. We could have highlighted it or just put the cursor there and hit Control-K-C. Or we could have just put the cursor here and gone up here and found this button. I think it's this one here. Yeah, and that would also put a comment in. I'm big on hotkeys, so every time I use a hotkey, I will tell you what hotkey I'm using. I feel that the more times that I got to get my fingers off the keyboard to a mouse is just wasting my time. So in order to declare something, as you remember, we had booleans, bytes, characters, integers, all different types of values, all different types of data types, value data types. And the way that these work is, I'm just going to put this at the very top in a comment, is you put a type in. So what data type? So I'll actually spell that out as data type. And then you put a name or a variable name here. And then you could put an assignment operator, which is an equal sign, and you could put a default value if you wanted to. So for a bool, if we were putting in a bool, say we call it a flag, and that would be our default value would be false. And we could come down and say console.writeLine, and we'd say flag. Now the console is an object that's in the system class. If you mouse over it, you'll see the system namespace, and we'll get into namespaces later. But the console is the actual object, and writeLine is a static method. Okay, that takes in a 19 different parameter types. So as you can see, as I'm going through these, you can put just about anything in there and it will print it out. Now, if you have a custom class, you would have to override console writeLine if you wanted to write it out. But most of the time, if you have a custom class, you want to write data out, you're going to create a method called display. And we will get into all of that. For right now, you're just going to say Boolean flag is equal to false. All right. And then you're going to say console writeLine flag. So let's get this thing running. And that is also F5. And you will see value types in false. So what has happened here is you've just taken the value of this variable and printed it to the screen right here. You don't have to put the default value up here. You can do this and then put the value down below. And you can make this true if you wanted to. Doesn't matter. And if we were to run this with F5, you would see it comes out as true. Now, one thing that you need to keep in mind is C# is case sensitive. So if you put a T, capital T in there, it's not going to know what that is. And you're going to get a find install latest version of something, change true to true. It's going to give you some errors, especially when you compile it. If you hit Control-Shift-B to compile, you're going to see the name true does not exist in any content because it doesn't know what it is. However, true is a key word. So that's all I'm going to touch on with Booleans for the moment. But I will tell you, Booleans are extremely important, and Boolean logic is extremely important inside of C#. And as we go through these, we will continue to grow your knowledge of Booleans. The second thing is a char, and some people call it a char, but it's for character. But a lot of us still call it a char because that's what it was called back in the 70s. So you put a C in there, and don't worry about the Unicode right now. We're just going to say I want to put the letter A in because this is what 99% of the time you're going to be doing. And we will build on the char later. So this here will just assign the letter A to CH. And again, there's your A. I'm going to leave these guys where they're at the moment, and we're just going to comment them out. So here's another way of commenting, and that's a star, and then like this. So you start with a slash and then a star, and this is anything in between. If you keep on hitting enter, you'll keep on getting these little asterisks in here. So sometimes we call these splats. If you meet anybody that's in database land, they'll call that a splat. But we'll comment these out. And now we're going to get into the integral numerics. Again, with the whole data type, variable name, default value, we're going to put in here byte. And you can see it automatically wants to build something that we don't want. So we're just going to use the letter B for the name. And we're going to name this A5. And I'm going to put next to this, the value would be in binary. So this is a 1, a 2, there's nothing in there. There's a 4, and that's a 1. So 4 plus 1 is equal to 5, and that's how we get to 5. Now, we're going to print this out so you can see it, that it does come out as a 5. It's not going to come out in binary. But as I was saying before in the video, that you could take this byte and I could make a short and call it S and assign it to B. And that will take that 5 and put it into the short. And we could take that short and make this an int, or let's just make it I and make it equal to B. And I can make this a long, we'll call it L, and I can make it equal B. Or you can make it S, or anything that's smaller than it. So we put this in here like B, S, I, and L. When we run this, we get 4 or 5 stacked on top of each other, because that's what this here did. So why does this work? So remember, like, this here is the byte, right? And remember, this byte goes all the way out here somewhere. The short actually looks the same way, except for it's got more values to the left of it. So these get dropped in and they get copied, and there's not any big deal, because you're just dropping these guys in. Click, 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 all the way down. So like, I'm not going to go through all these because it will take a while. But this is what I am talking about. So here you have, int is 32 bits. So if you count this up, you got 4, 8, 16, and then 32. All of these guys need to get moved out to line everything back up. Okay, so they just come in. Now, if you were going the other way, you could do this as long as you did something like this. So I'm going to comment this out. First, I'm going to copy it, and then I'm going to comment it out. And we're going to drop it back down. We're going to go, and I'm going to put an int up here at the top. And we're going to name it like this. And then this is going to be a short, and this is going to be a byte. And I don't think we really need a long for this demonstration. But notice, as soon as I start putting in, S is equal to I and B is equal to I, we get these little red curly marks here. And the reason for that is because you cannot put an integer into a short. So the integer looks like this, and the short looks like this. Where are these digits going to go? There's no place for them to go. So in order to put them in, you're going to have to do something called casting. Now, you know that a 5 is less than 32,000, right? It's greater than negative 32,767 or 768, and it's less than 32,000, so it will fit in here. So casting says, I'm going to cast this to a short, and you're telling the compiler basically to ignore this issue. You know what you're doing. And the compiler will tell you during the runtime, when you run your program, will tell you whether or not you really know what you're doing. So here is a valid statement. Now, these casts of an integer into a short get a little tricky. So first thing, let's just run this to make sure that it did what we think it did. And it did. Each one got a 5. Now, if we put a 256 in here, 256, 256, and 0. So that makes sense, right? I mean, you could put 256 in here. So if this was 8, and these are all zeros, right? We're putting in 256. Everybody's getting a 0 here. So you go 8, 16, 32, 64, 128. This would be 256, and that would fit just fine into the short. However, there's no place to put that in here for the byte. So what if we go to 257? You got 257, 257, and a 1. Now that's kind of weird. it is and it's not, because the only thing we're doing is we're copying down this number. So here's 257, and we copied this into here. These are just getting thrown away. So there's our 1. So a lot of people think of this as going around, like you're going 255, 256, and then, that's the beginning of the entire thing at 0. And then you go 1, 2, 3, 4, all over 255. But that's not really the case. These are actually being copied into place. It's just that we can only accept the first 8 of them for the byte. And it's the same thing when you're working with a byte. Like if you're working just with the byte or just with an integer. So let me bring these down here. And we're going to put the byte in here, but I'm going to put in here 255, right? And we're going to comment all this out, Control KC, and take this with us. So we're going to put 255 in, and that looks like this. 1, 1, 1, 1, 1. All right, and this will work. You'll see it'll come up. It'll say 255. That's the maximum number you can have. Okay, so the 255 worked out just fine, but what if we add 1 to it? What's going to happen with that? So when you add a number to this, you're going to get 0, 0, 0, 0, 0, 0, 1, and you're going to add these together, okay? So the result of this comes out to be everything's got to move over 1, right? Because you're going to say 1 and 1, well, that goes to 0. And you carry 1 and 1 and 1, and that goes to 0. And all of these end up till you get all the way down to the end here, and you get a number that looks like this. Right? So there's no place to put this because we've only got 8 bits. So the value that's going to come out is going to be 0. Now what happens if we add another 1 to this? Okay, so here's another one that's going to get added. Well, this has already been moved out, and so same thing that happened up here. This is going to move down 1, and our value is going to be 1. Just like that. So these are things that you need to think about a little bit. All right. Now, if you feel more comfortable with saying that a byte goes from 0 to 255, and if we add 1 to it, then we end up, going the roundabout way, and it goes back to here, and it just starts all over again. That's fine. I know a lot of people that they go down that path because they don't know the Boolean and the binary logic. So if you want to go down this and it's easy to remember, then by all means remember it that way. But the thing is when you're breaking down a short from an int, or putting an int into a short or an int into a byte, this can be dangerous. So you may be losing bits, okay? So think about that. So the next thing that I want to talk about is floating point numerics. And these are a pretty quick topic. There's only 3 types of them. One is called a float, and we're going to name this F. There's another that's called a double, and we'll name that D. And there's another one that's called a decimal, and we'll name this DM. So a little more information on the differences between the 3 of these. A float is 4 bytes, a double is 8 bytes, and a decimal is 16 bytes. So if you think about this, your float is taking up the same amount of space as an int. Your double is taking up the same amount of space as a 64-bit long. And the decimal is like a double long. So the further down the list here you go, the more precision you're going to get. And as you can see, the float is about 6 to 9 digits. The precision of a double is about 15 to 17 digits, and the decimal is 28 to 29 digits. Now, where's these abouts coming in? Well, let me show you. If you take a float and you say it is going to be equal to 1.0 f, and you take that same float and you say I'm going to multiply this by 2.9999 99F. And then we write this out like that, and we run this. You end up with 2.999999, which you would have expected. The difference is if I put another 9 on this and run it, we're into the 7-digit mark. Okay, and that turned it to a 3. I know a lot of you are going, well, yeah, that's cool, it rounded up. But the thing is this could go another direction too. You could end up with 3.01. You could have ended up with 2.98. It all varies on what these values are right in here. So typically in computers, we don't want to round anything, especially if we're talking about money or insurance or banking or insurance or anything like that. So let's do this the same thing here with a double, and I'll put a D there. And with the double, you don't put the F on the end. And we'll run this again. And you will see that the double will come out with the 7 9s. Let's extend this out to 16 digits. So right now we're at 7, so let's go to 8, 9, 10, 11, 12, 13, 14, 15, 16. And that rolled up to a 3. All right, so if you're dealing with things that got 16 digits of precision, you don't want to be using a double. Now, what about a decimal? Since we're using a decimal, you got to put an M at the end. That's why I called it DM. This here will go out to 28 or 29. So here's 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. We'll go to 28, 29. Yeah, we'll do 29. And then let's this is a roll. And now you're getting 3 point and a whole bunch of zeros. Okay, so let's see where we can go back to. So that would be 28. So 28 digits to go out on a decimal. If I'm writing a banking or an insurance or anything to do with paying bills or money or anything, I'm definitely going to use a decimal. And this is all you really need to know about floating points. You got floats, least precision, doubles, the medium precision, and the decimals are the most precision. So, like I said, that's about all you're ever going to need to know about floating points. We will build on them as time goes, because there's some things with multiplication and division and little things like that that you need to know about.
Thanks for watching the video. Please like and subscribe to the channel. I really hope you enjoyed this video, and I hope that you understand more about how memory works and how managed applications work. If you have any questions, drop them in the comments below. In the next video, I'll start talking about conditionals, and then we'll move into looping. These are the building blocks of a foundation that is used to write every application that's ever been written. A developer needs to have a solid foundation in order to understand advanced programming concepts. Every great developer has this foundation. You're always welcome here at the C# Workshop, and as always, have a nice day.